Hey guys, welcome back to my channel and I hope you are all doing extremely well. This is lecture 6 on my linked list series. So far I covered 5 lectures and from lecture number 4 we started solving actual problems and I am taking these questions based upon Geeks for Geeks and Lead Code curated most asked frequently interview questions. I highly recommend you to maintain the sequence. That means start seeing from lecture 1 till whatever I'm going to post in future so that I assure you can going to learn lot of things in this series and you will become very strong in solving the problems on linked list. So without further delay, let's get started with today's lecture. So today we are going to solve one of the lead code medium level question on linked list, that is nothing but rotate list, problem number 61. Let's try to understand this problem statement. We will be given one list along with a k. So the ultimate goal is we need to move nodes to the right side by k places. So what does it mean by? Let's try to understand in a diagram for a better understanding. If my list is something like this, 1, 2, 3, 4, and 5, and 5's next is null. And if my k value is equal to 2, so the ultimate goal is, so I need to move my k nodes to the right position. Okay, so that what will happen? So first time I'm going to move 5 to the right, then my output is going to look like something this 5, 1, 2, 3, 4, and 4's next is going to be null. And then I'm going to move my 4, then my output is going to look like 4, 5, 1, 2, 3, 3's next is null. So if you carefully observe, so we moved our nodes to the right side by k places. Okay, if k is 2, then we need to move 2 nodes to the right. If k is 3, we need to move 3. Okay, this is all about the problem statement. Let's see how we can solve this problem. If my list is something like this, 1, 2, 3, 4, and 5, 5's next is null. And here you can observe my head is pointing to this. I'm denoting with H. So here you can observe my length of list is what? 5. So if given k is divisible by length, that means it is a multiple of my length, okay, then what you are going to return? You are going to return your original input as output, right? So assume my k is 10, okay, so 10 divided by 5 is going to be 0, okay. So in this case you need to return your original input as output, because if you start moving 10 nodes to the right places like 5, 4, 3, 2, 1, again 5, 4, 3, 2, 1, so you end up going to have the same input as the output. So that is the first case we need to look forward for. Now let's try to see how we can determine our k value. So let's assume my input list is 1, 2, 3, but my k is 4. So that means I need to move my list by only one position to the right. Why I am saying like this? Because if I move k by 3 times, then I'm going to get my same input as an output. But when I do the fourth time, I'm going to get a different output, right? How you can determine? So the simple formula is k equal to length minus k mod length. This determines how many times you need to rotate your list by k places to the right. Okay, let's take this example. So length is 5. I'm applying this formula here. So 5 minus k, here they given as assume 2. Okay, 2 modulus 5. So what is your output is going to be 5 minus 2 mod 5 is going to return you 2, then 3. So if you start uh, pointing to your third node and you break this link and you connect this to the this, then if your head pointing to this, then you are done. Seems confusion, right? Let me break you into the smaller chunks. Here my list is like this: 1, 2, 3, 4, 5. The first and foremost step is we need to form a loop. Okay, how we need to form is our last node should connect to our first node. Okay, I can tell you why we are doing like this. So if my start node connecting to the first node, then I can see there is a loop. Now my goal is I need to know the actual k rotations. Okay, I need to apply that formula. So 5 minus 2 mod 5, that is nothing but 3. So what we need to do here is, so starting from head, our head is pointing to here. Starting from head, move till k positions to the right side. Okay, what I mean by that? So we need to come in this direction. So what will happen if I come by one position? Okay, I will be here only, and if I come by two positions, I will here only. If I come by three positions, then I will come by here. Okay, then you can see here I am at 3. Okay, in order to get my required output, I need to break this link and I need to mark this as a head so that your output is going to look like 4, 5, 1, 2, 3. Right, so this is what actually we need. So what we are actually doing here is, so we are forming a loop, okay, and we are going to k nodes from the beginning, and we are breaking the link, and we are marking the next node of current node. Assume this is current node next is head, so that you are going to get the required output, and then you need to return this one, of course. Okay, and I hope you understood the solution approach. If not, please do let me know in the comment section. I will be very happy to help you. So, what are the time and space complexities here? The space complexity is going to be big of n because we are not taking any additional data structure to process the request. So, what is the time complexity? The time complexity is going to be big of n on an average. So, that's all for the explanation. Let's get into the coding part. Yeah, here is I am. So what is my first base condition is going to be? Yeah, if head equal to null or head dot next equal to null or k is less than 0. In this all cases, just return your head. Okay, otherwise take a one pointer car node, one reference I mean to say head. Okay, and take a variable length because we need to know the length of list. Initially I'm starting with 1 while kernode dot next not equal to null. Till this condition satisfies, let's increment our length and let's move our kernode by one position forward. Kernode dot next. As soon as we found a node whose next is null, that means that is the last node in the list, then connect that to the head. So simply do kernode dot next is going to be head. So with this you formed a loop. Now you need to determine the actual k value. Okay, so for that k equal to k minus sorry length minus k mod length, which will give you the actual k value to perform our rotation. Okay, now while k minus minus greater than 0. Okay, till this condition what you need to do, you need to forward your kernode dot next. Once you once you are at the position 3 here, if in our case once we are at this position 3, then the ultimate goal is your kernode dot next is going to be head, and then your kernode dot once you give your kernode dot next as a head, then you need to break this link. Okay, let's see that. Here what we have, so if our kernode is standing at this position, then we need to break this but before this, we need to make this one. Okay, so that your head is going to be kernode dot next, and your kernode dot next is going to be null, and at the end return your head. Return head. That's all for the coding part. Let's run it. Uh, okay, it is list node, not node. Okay, yeah, let's submit it. That's all for this problem. So it got submitted successfully, and I hope you learned something new today, and I wish you all the best in your learning. Please do subscribe to my channel, and I'm going to upload more valuable content on my channel. Thanks a lot. Bye bye.